Hello everyone, my name is Tioren Han with the metric number of 23005099. So in this project, I am to predict the velocity of a racing car along a straight track, considering the engine force, aerodynamic drag, and the rolling resistance. I used both analytical and numerical methods in the MATLAB for the simulation. I applied three methods, which are the Euler, RK4, and the analytical method. Euler is simple but less accurate. The RK4 is more precise with 4 slope estimates, and the analytical method gives the exact solutions and serves as a benchmark. So these are the key variables used, such as the mass, air density, drag coefficient, and more in order to simulate the car's velocity accurately. I derived the motion equation and defined the constants such as K1, K2, and K3 to simplify the coding. These constants represent the force per mass, drag, and resistance. Here I show the Euler and RK4 formulas. Euler uses a basic slope update, while the RK4 calculates 4 slopes per step for better accuracy in nonlinear systems. The analytical solution is derived from the same differential equation using the calculus. It gives the exact velocity over time and is used to verify the accuracy of the other methods. I also used the true relative percentage error to compare the Euler and RK4 against the analytical values. This quantifies the accuracy of both numerical methods. In the code, I defined the constants, set simulation time, and created arrays for the Euler and RK4 velocities. I calculated the analytical solutions and printed all results in a formatted table. Now, without further ado, let's move to the MATLAB software to show you the running of the code. So first of all, as you can see here, I defined the constant like the engine force, drag, and resistance, then implemented the Euler and RK4 loops, as you can see here also. Okay, I calculated the analytical solutions, and finally, printed a table with all results and percentage errors. So let me show you how to run the code correctly. So first of all, you need to click the editor here, and then inside the editor, you will see the run button, and then you just click the run button. Okay. After clicking the run button, the code executes successfully and displays everything as expected in the command window here. Okay, so this means that our code is really working and is successful. Okay, now let's go back to the presentation slides and continue our presentation. Okay. To run it, the user extracts the file, open the .m script in the MATLAB and click the run button to view the output in the command window. The program solves a motion problem with given inputs like the mass, drag, and engine force. It runs from the 0 to 20 seconds with a step size of 0.5. Set up all initial conditions and coded Euler, RK4, and analytical solutions. The output table shows velocity using all three methods. Euler approximates the trend but with more error. RK4 is much closer to the analytical solution. The simulation is helpful for modeling the real-world vehicle dynamics. Okay, so I observed that both methods show the car accelerating toward the terminal velocity, and then the RK4 values closely match the analytical result, validating its higher accuracy. Okay, here are the screenshots of the result from the MATLAB. So this confirms that the code runs correctly and provides the clean output. So the Euler is efficient but less accurate over time. RK4 keeps errors low even with the longer simulations. Although it needs more calculations, it is more stable and suitable for nonlinear systems. Okay, the analytical solutions validate both methods. RK4 remains accurate with the various step sizes, and I also explore how parameter changes affect the velocity, showing the practical uses in engineering. Euler is quick and simple, ideal for early stage simulations. RK4 is more accurate and better suited for precision modeling, especially under the complex force conditions. Okay. Okay. I led the assignment setup and defined the objectives and assigned tasks. I implemented the Euler and RK4, derived the analytical method, wrote the full MATLAB code, calculated the errors, and formatted the outputs. I also supported my teammates with coding and final checks. Through this, I believe that I improved my programming, analysis, and teamwork skills while learning to apply numerical methods in engineering effectively. So that's all from me. Thank you. By the way, for my part, I have used the two numerical methods to solve my subproblems. And our team total will have uh, 7 methods of the numerical methods in this PowerPoint slides to solve our subproblems. So that's all from me. Thank you.